Okay, fourth graders, we are here on our last of our 3 review pages for Unit 5. I'm on page 207 of my book, and we're starting with number 15. A rectangular scarf has an area of 192 square inches. The short sides of the scarf, are each 6 inches long. Use the labels from the list to complete the model. Labels can be used more than once. Okay, so obviously you'll be doing this online, so they'll have something like this where you'll probably have to drag and drop the different numbers into the model. So first of all, thinking about what clues they have given us already. We can go ahead and circle 192. We can circle 6. We might want to underline the word each. It means something slightly different in this problem, but it's still a good thing to underline and be aware of. And then I'm going to put a big rectangle around this word right here. Area. I think it's really important that when you see that word, immediately you think about it and you, in your brain, you go over the difference between perimeter and area, because that is where the most mistakes are made on these. So we remember that area is not the distance around a shape. Remember, that's perimeter. Area is made up of little squares covering the inside of the shape. So we've gone over this quite a few times, but it really helps to say it as many times as you can to yourself. Area is inside. It's all these little squares inside. So the formula for the area, remember, is length, and we do that with a lowercase l, times width, lowercase w, equals capital A, equals area. Okay, so the numbers that they've given us so far is 192, and that is the actual full area. We're going to put that in here, 192. You might recognize that from when we were doing area models, when we were learning multi-digit multiplication. And we actually used the same kind of model when we first started long division. So we're putting the big number in the middle. Remember that represents that this times this is going to equal that. So looking at the outside, where do we think that the 6 would fit in best? It says the short sides. Okay, so 6 is going to go over here. Now, they gave us a pretty big hint. They said that labels can be used more than once. That means they probably will be used more than once. Anytime you see that on a test question, it's a pretty big hint that you're probably going to be using them more than once. So we've got 6 on both sides here. The last thing that we need to figure out is what it's asking us, which is, this part at least, what is the length? So length equals question mark. So a lot of these we're going to have to go backwards on our formula. We know that length times width equals area. What is multiplication backwards? It's division, right? So we're going to take 192 divided by our width, which is 6, and then that equals whatever our length is going to be. So we'll have to set that up. I don't know about you, but I'm not going to try to do that long division in my head. 192 divided by 6. I've noticed as I've been working with some of you this week and last week, long division is something that we keep needing to review and practice. So please don't skip on this. Don't use a calculator because you have one at home. Actually do the long division. You're going to have to be able to do it for 5th grade. Your 5th grade teachers are going to expect you to be able to do it right away as soon as you get into 5th grade. So because of that, you do want to make sure you're practicing it during this 3rd trimester of 4th grade. 19 minus 18 equals 1. We bring down the 2. Back to dad step. 6 goes into 12 2 times. Mom multiply. 2 times 6 equals 12. Sister subtract. There's no remainder, nothing else for brother to bring down. Okay, so we've got 32 up here. In the answer key, they actually put L up in these two because they were just showing the model before we figured it out. So just know that online, they might have you just put L in there or W if it's the mystery number. Okay, part B. What is the perimeter of the scarf? So we had the area and now we have the length, but we don't have the perimeter. So remember, perimeter is all about adding. We multiply for area, we add for perimeter. So we always have to add up 4 numbers, unless we're getting fancy, which we've already gone over. 32 plus 6 plus 32 plus 6. You can keep it really simple for yourself that way. If you add up those 4 numbers, you're going to get 76 inches. And of course, it's asking you to explain your work, to show your work. So if you have to explain how you did it, you would maybe put in the formula, length plus width plus length plus width, or you might show how you added them all up. Number 16, a rectangular cafeteria tray measures 18 inches on the long sides. It measures 12 inches on the short sides. What is the perimeter of the tray? Okay, so we know that it is 18 by 12. I like to draw little models for these. I just think it's helpful. They don't have to be perfect, but as soon as I draw it, then it becomes really obvious to me that there's going to be two 18s and two 12s. And I know that when I'm adding all of those numbers up, I'll get the perimeter. So please have scrap paper handy. Please do your drawings and your models. It will help you as you continue in this unit. Number 17. A bag of rice has a mass of 3 kilograms. Jackie buys 17 bags of rice for the school cafeteria. How many grams of rice did Jackie buy? Explain how you solve the problem. Okay, so here's our first conversion problem of these 2 pages. We've got kilograms happening here, and we've got grams happening for our answer. Okay, and then of course we're going to have to explain. So remember what I've been telling you. I like to do the math first, if at all possible. I think it's easier just to get that out of the way, and then we can do the conversions. It usually means we're working with smaller numbers too. So what do you guys think? 3 kilograms, 17 bags. How many kilograms? How could we figure that out? 3 times 17 would be your answer there. So 3 times 17 equals 51. And we know that that's still in kilograms. I'm going to write kg there because that'll remind me I haven't gone to grams yet. I haven't done my conversion. Okay, I like to use my King Henry thing. You can use the one in your book. You can use whatever you want. But remember, we're counting hops. So we're going from kilograms to grams, to our basic unit. So looking where before I leap, I have to decide how many hops I'm going to take. 1, 2, 3. So in my head, I already know that I will be adding 3 zeros. And if you ever forget, if you're adding zeros or moving the decimal point backwards, you can just look down here. If you have this chart, it says multiply by 10 if you're going to the right. So you're always adding a 0 when you multiply by 10. Okay, so 3 zeros. 51 kilograms equals 51, and then 3 zeros. 1, 2, 3. 51,000 grams. So my final answer there is 51,000 grams. And then of course I could explain how I did it by talking about how I know how many grams are in 1 kilogram. I could explain how I used my chart. There are many different ways to explain how you got your answer. Okay, so now we're looking at true and falses to see if we have these conversions correct. So the first one is 8 feet to 96 inches. So the very first thing I need to think about is, how would I convert feet to inches? What would my conversion number be? You're allowed to look this up if you don't know it, but you should try to start memorizing them. There are 12 inches in 1 foot. So I know 12 is my conversion number. But now I have to decide, am I going to be multiplying or dividing if I'm going from feet to inches? I know I want a bigger number because there would be more inches in a space than there would be feet in a length. So 12 times 8 equals, if you know your 12s, it equals 96. So that is true. All right, let's check out this one, 18b. 9 pounds to 72 ounces. All right, so again, I'm going to go from 9 pounds and convert that to ounces. So I have to think, how many ounces are in 1 pound? 16. And if you don't know that, that's okay. Remember, you can always look it up. So again, I've got my conversion number. I'm deciding if I'm multiplying or dividing. Obviously, I'm multiplying. I'm trying to get to this bigger number. 16 times 9. Okay, and 16 times 9, I'm actually going to set this up. 9 times 6 is 54. 9, 10, 11, 12, 13, 14. Ooh, 144. Not 72, so false. All right, our next one, 8 pints into 4 quarts. So first of all, you have to know how many pints are in 1 quart. This is one that I usually have to look up. I happen to know it right now in my head, but sometimes I have to look it up. There are 2 pints in 1 quart. So if I'm going from pints to quarts, I'm going from bigger to smaller. So I would divide by 2, or I could think about it as going from 4 to 8 and multiply by 2. Either way, I can see that it would work, right? 8 divided by 2 equals 4, so that's true. 3 yards equals 36 feet. Oh, this one's in here to trick us. You know why? Because 3 yards does equal 36 inches, but it does not equal 36 feet. Let's check it out. 3 yards to feet. How many feet are in 1 yard? 3. So 3 times 3 equals 9, not 36. So that is false. But you notice that they threw that 36 in there as a trick. Okay, 4 gallons to 16 pints. So this one actually goes for more than one step. We have to think about how many pints are in a gallon, and we can think about that in many different ways, or we can just go 2 steps. So I'm going to show you the 2-step way. So I know that there are 4 quarts in 1 gallon. So 4 gallons times 4 equals 16, but that's only in quarts. Oh, look, it's a trick. So then I have to go times 2. Remember, we learned that there are 2 pints in 1 quart. 16 times 2 equals 32. So that's false. But again, they love to throw numbers in there that look correct or that you've seen. Yes, they keep us on our toes, don't they? A movie starts at 12:45 p.m. and is exactly 1 hour and 35 minutes long. What time does the movie end? Okay, so first things first, we know that it's going to be at least 1 hour later. So that's the simple part, right? 12:45, what's 1 hour after 12:45? It would be 1:45. So you'd keep the minutes the same because you're just changing the number in the hour. We could almost call that the place value, right? The hour place, the hour. Okay, so the minutes have stayed the same. So I'm at 1 hour, so 1:45. But that is not where I'm finished yet. Now, thinking about the minutes here, 45 plus 35 is going to go over 60. And we've talked about this, how when we're in time, it's not base 10. So we can't just, I wish we could, but if we added those two up, we'd get something over 60, maybe closer to 90, right? Maybe even bigger than that. It'd be 80, I think. So because of that, I've got to count forward 35 minutes, okay? So I'm picturing a clock here, and I'm thinking, okay, 1:45, how many minutes would it be to get up to 2 o'clock? 1:45 to 2 o'clock would be 15 minutes, okay? So 35 minus 15 is, I'll just go ahead and do my work here to show. It's the best way to make sure I don't make a mistake. Okay, so 20 minutes left. Do you see how I did that? I first took it up to 2 o'clock. So now I'm at 2 o'clock, but I still have to add 20 more minutes. So 2 o'clock, 20 minutes later is going to be 2:20. If you have a clock at home, I highly recommend doing it with a clock, because then you can draw a picture of a clock. Then you can, literally do your marks around the clock. Okay, part B. It takes Lynn 25 minutes to get to the movie theater. She wants to meet her friends at the theater at least 15 minutes before the movie starts. What is the latest time that Lynn can leave her house? Explain how you found your answer. Okay. Again, a lot of 4th graders make the mistake of starting with this number since we just found it. But this is when the movie ends. This whole problem is talking about when the movie begins, right? And how long it will take her. So we're going to go back up and find when the movie begins. There it is. It's at 12:45. So that's going to be really important to us. It takes her 25 minutes to get to the movie theater. Let's just start with that. So what time should she leave if she wants to be there right on time? So it's 25 minutes before 12:45. Now in this case, subtraction will work, 4th graders, because you're going down from 45 and you're only going down 25. So let me show you what I mean there. 12:45 minus 25. That's because we're still going to be in the 12 o'clock hour. We haven't gone back far enough where we've headed to the 11 o'clock hour. Okay, so 5 minus 5 equals 0, 4 minus 2 equals 2, and then, like I said, we're staying in the 12 o'clock hour. So if she wanted to be there right on time, right when the movie starts, she would leave at 12:20. But she doesn't want to be there then. She wants to be there at least 15 minutes before the movie starts. So we're going to figure out, since it says what's the latest time, we only have to stick with 15. We don't have to worry about like maybe even earlier. We can just go with the 15. What do you think? What's 15 minutes before 12:20? Do you think we can subtract again? We actually can, because look, 20 minus 15, we're still going to have an answer, and we're still going to be in the 12 o'clock. It'll just be almost past 12 o'clock before that to the 11 o'clock hour. So we're going to subtract 15. Sorry, that's kind of sloppy. And we end up with 12:05. And remember, 12:05 is answering the latest possible time that she could leave and still be there 15 minutes early. I think this is going to be one of the hardest problems on the test tomorrow, Thursday. So really take some time to practice this problem and ask your parents or ask your family members to give you more problems like that if you can, to really practice those elapsed times. Okay, last question of the day is number 20. Choose a number from the first column and a unit from the second column to make a measurement that is equivalent to 2 meters. All right. Okay, so 100. We have to see if 100 is going to be any of these equivalent to 2. But some of you are already thinking, wait a minute, Miss Dye. 100's never going to be equivalent. 100 nothing is going to be equivalent to 2 because it doesn't keep the 2, right? When we're in the metric system, when we're using our conversion chart, we're keeping that first number the same and we're just adding zeros or moving the decimal point back, but it would still be 2. So I know that 100 is just not going to work. I'm going to cross it out. Okay, what about 20,000? It does have a 2 in it. So then we're seeing, would it work over here? Could it be decimeters, centimeters, or millimeters? This one takes we have to play around with this one. It takes a little bit. Okay, so let's find out. Let's say 20,000. Let's see what 20,000 would be. So we're at 2 meters. If we hopped over, how many zeros is that? 1, 2, 3, 4. 4 hops. So 1, 2, 3. What? Look, 4 hops is going to be over here, and we haven't learned that. So therefore, 2 meters, I don't think we're going to be using 20,000. They wouldn't use something that we haven't learned. I don't even know if there exists something tinier than millimeters, actually, because those are super tiny. But you never know. You should let me know. Research it and let me know. Okay, so now let's go with 200. I think this is the only one that realistically is going to work. 2 meters to 200 something. Okay, 2 meters. So 200 means that there's 2 zeros in 200, so it's going to be 2 hops. 1, 2. Oh, okay. Centimeters, right? 200 centimeters. Yes. All right, so 200 and centimeters. Okay, so notice that there's only 1 out of the number and 1 out of the unit that can be correct. All right, guys, good luck. Do your best, and we will be working through this and then taking the quiz later. The test later. Bye.